Hello, welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video we're starting a new chapter. We're looking at stacks and queues, and in a more general sense we're going to start talking about abstract data types, ADTs. So an abstract data type is basically, in some ways it's a concept, it's a way of storing information and getting that information back that is abstract. Now we've seen the keyword abstract in Scala. When a method is abstract, it means that it doesn't have an implementation. When a value is abstract, it means that we declared that it would be there, but we didn't define it. When we had one of those in a class, we had to put the abstract keyword on the class, which meant we couldn't instantiate it. In some ways, the meaning of abstract is holding the same here. These are going to be data types that we say at a certain level what they do, but we don't say how they do them. Okay? And that's kind of what happened with our abstract methods. Our abstract methods would say, you have to have a method, it takes these arguments, it returns these values, but we're not telling you how that's done. And then the subtypes would tell you how it's done. Same type of thing is going to hold here. Now, the two abstract data types we're going to start with are called the stack and the queue. And we start with them, of course, because they're the simplest examples of ADTs. So, what is a stack? Well, your mental image for a stack should be something like this. This is a plate dispenser that you might have in a cafeteria where plates get stacked up. You can think of any other stack of things, like a stack of books, but when we really officially, the formal definition for how we want to use our stack is like this stack of plates in that you're only allowed to touch the top one. Okay? So if you want to get to the third plate here, you actually have to pull off the two above it first. Also, the terminology that we're going to use fits the image of the plate dispenser. You'll see we'll use the methods push and pop. And indeed, when you put a new plate on top of here, it pushes the stack down. And when you pull plates off, everything pops back up. So that's the mental image behind the stack ADT. The queue ADT, for many English speakers, the queue is actually what you do when you get when you line up someplace. So in the U.S. we talk about getting in line. In England they would say you get on queue, and so here's when people line up to do something, they intend to be serviced in a particular way. And so this is basically what our queue is going to do for us. And so in this video, I just want to start working on the abstract part of this and show how we're going to put this into code. And I want to talk about the methods that I want us to implement on our stack and our queue. I'm going to go ahead and I'm going to create a new package. And I'm creating this because we are going to be making more ADTs in the future. So I'm going to make a package called ADT. And then all of the ones that we make in future chapters will go in here. And of course, the first one that I want to make, and because this is completely abstract, I am going to go with making this a trait as opposed to making it a class. Now I could just call it stack. It turns out there's a stack in the libraries, so I'm going to go with my stack so that I don't conflict with it. And I will also want to create a my queue. Another trait, my queue. Okay, so what methods do we have on our stack? The two most important methods that we have to define in here are called push and pop. Push, def, pop. Okay. Push is the method that adds something onto the stack. So let's go back here to our, when we push onto the stack, we're adding a new, in this case, plate onto our stack, and everything gets pushed down. And when we pop, we're supposed to take that thing off of the stack. To help make things work, I'm going to put in two other methods. I would like to be able to check if the stack is empty, and I would also like to be able to peek at the stack to see what the top one looks like, okay, without removing it. Whereas pop gives you back the thing from the top. Peek just looks at it and doesn't remove it from the stack. Now obviously I left these somewhat incomplete. When I push, I have to pass something in. I have to say what is it that I am pushing onto my stack. So I'll give it a name. I'll call it O. That's for variable name for something. It's an object. What is the type of O? Well, what should our stack be able to hold? I want this to be polymorphic. I want this to be abstract. I really don't care. I mean, obviously a picture it's holding plates, but I should be able to put ints on this, or doubles, or strings, or anything that I want. And so it's tempting to say that you make this a push so it takes type any, but the problem with that is that most of the time when we use a stack, we actually want it to only hold one type. So if I make a stack, I want to be able to say I have a stack of ints, okay? As opposed to if I do this, well, then it's a stack and you could put one int on it and then a string on it and then put a student object on it, okay? You could do all types of things on here. So we really don't have any type safety. We don't have any control over what goes into it. You can mix and match all you want, and most of the time that's not what I want, okay? So the way around this is we are going to use, going back to our chapter on polymorphism, we're going to use a type parameter here. We're going to say that my stack takes type A, and then when we push, we're going to push an object of type A onto the stack. And push doesn't need to give us anything back. What about pop? Well, pop doesn't take anything. No arguments go into here. Now I'm putting the parentheses here because pop does mutate the stack. Okay, we're making a mutable stack here. And it's considered part of the style of Scala that if you have a mutation, even if you take no arguments, you should probably put the parentheses there to make it very clear this is a function that's being called. But pop does give us something back. Okay, when I pop off the top of the stack, I should get back the element from the top. Is empty? Well, it's asking a yes/no question, so it'll return us a Boolean. And peek returns an A. Now note here that based on the arguments for why I put parentheses here, I don't necessarily need to put them here. Okay, this is, once again, it's a style issue. You can put them if you want. I'm going to leave them off simply because peek doesn't mutate the stack. It just gives me back a value, doesn't change anything about it, and so I'm perfectly happy having it so that people can call it without having any parentheses there. Now, what about our queue? Well, it turns out we want nearly the same methods, and we also want our queue to be able to hold whatever. The only difference is I'm not going to call them push and pop, because that whole mental image of you push, the plates go down, you pop, then the plates spring up. When you get online, we'll say that you enqueue something, and when the person at the front is serviced, we dequeue them. Okay, so just like with the stack, instead of having a push, we have an enqueue. It adds one element, and instead of having a pop, we have a dequeue. It removes one element. I still want to be able to check if I'm empty, and I can still peek at the next thing that would be dequeued without taking it off. Okay. So these are the four methods. Now, there's a lot of similarity between the stack and the queue. And other than I change the names of these things, this adds, this removes, this adds, this removes. So what's the difference? Well, the difference is, and this is what is part of kind of the contract of the ADT of these things. For a stack, when you pop something, what you get off is the last thing that was pushed. So if we go back to our picture, if I put on a bunch of plates here, when I pop one off, the one that I get is the last thing that I added. On the other hand, when you get it online to be served someplace, your assumption is that you get on at the back of the line and you're not going to be served until you've gone all the way up to the front, and that the person who's being served is supposed to be the one who's been there the longest. Okay, so the queue also has an add and a remove, but the fundamental difference is that the contract of a queue is that dequeue is going to remove the thing that's been there the longest, whereas the contract of a stack is that pop is going to remove the thing that has been there the shortest. That's the basic idea of our ADTs here. And note, these are completely abstract. I'm not giving any definition. I have no idea how these things work. There's just a kind of a contract for these methods and what they're supposed to do. And so what we're going to do is we're going to come back in the following videos and we're going to implement these. We're going to use an array to implement them. And I also want to talk about some of the details for what my requirements are on how fast they work. But that will be in the next video. See you then.